the previous lecture, we have started with problem based on the regression lines, and we have seen how to find R, okay, and how to find the standard deviations and the variations using the lines given to us. Okay, so let us try to solve some more problems based on that. So we'll have another problem. Let us try this problem. What is given to you? Okay, we have given the line of regressions, and then we have given the variance of x, and now we have to find out x bar, y bar, r, and we have to find out what is the variance of y. Okay, so we have the solution. Okay, right, the line of regression of y on x p. What is the line of regression? So we can have y is equal to 30 minus 6x, or we can write this as y is equal to minus 6x plus 30. Okay, and I can write this as 6x plus y is equal to 30. So let this equation 1. This every form is only the equation 1. Okay, and hence we compare this with what is the line of regression? We have y on x. So we have y is equal to dyx into x. Okay, and then what you'll be having plus y bar minus byx into x bar. So the coefficient of x is going to be byx, and hence from this equation we can write. So we have byx is equal to minus 6. Okay, so let this equation 2. Okay, now we have to see what we can have is suppose we have this is going to be okay. So it shows that the slope of this line is going to be minus 6. Okay, and if you see what will be the slope of this line? Can you guess what will be the slope of this line? Now this we have to express as x as a function of y. So what will be the slope of this line if I consider x as a function of y? So here we are getting the slope of this line is minus 6, and what will be the slope of this? Minus half. So one thing is sure that both the byx and bxy is minus. Okay, so that is okay. But if I consider the product of this, what will be the product of this? Yeah, can you guess what will be the product of byx and bxy? Aarti, unmute yourself. Aarti Erole. The product, no, the slope is going to be slope. What you have to consider is now, see, here if I consider y is equal to byx, then this is going to be the slope. Okay, so here in this case, this is the slope of the line. If I consider in the case of this as a line of x, so what I'll be having is x is equal to bxy into y plus x bar minus dxy into y bar. This will we have. Okay. So here this will be the slope. So for this line, we'll have this minus x is the slope. For this line, what will be the slope we can have? So we have to express this as x is equal to minus half y plus 6. This will be the expression for this line. Okay. And now what is the slope we'll be having here? So this will be the slope. Okay. So if this is the slope and this is the slope for this line of y on x, okay, then what will be the product? What will be the product of these two slopes? 3. Okay, so is it good? What will be the square root of this? What will be the square root of 3? 1.73. What is that? What is the value you are getting? Square root of byx into bxy. What is the value that we get? R. So you are getting correct. You are getting R. R is equal to so what you got the value of R? R is going to be 1.73. So is a good value. Not possible. Correct. Okay. So that means it is greater than 1. That's good. Okay. So the value of R is going to be 1.73, which is not possible. Okay. Correct, Abhinav. The rank of the correlation of coefficient, the correlation coefficient is going to be either less than 1 or greater than minus 1. Okay. So the value is between minus 1 to 1. And that's why this value, whatever we have calculated, is not correct. That means these lines we are considering, we are going to consider are not correct. Okay, so that's not possible. So the line which I have considered as the line of regression of y on x is not correctly considered. Okay, so this is how you need to test whether your assumption or whatever you are considering is correct or wrong. Okay, so that means the line of regression of y on x we have considered is not correct. That is not actually the line of regression of y on x. Okay, so we have to change it. Okay, and that's why I asked you to calculate the things. Okay, so here we need to understand that the assumption we made was not correct, and hence we have to be careful in such cases. So what we have to do now is we have to consider the correct line, and then only we are able to get the correct answer. So let us consider the correct one. Okay, so we have, see, the line of regression of y on x. So we consider this, but it is not actually. Okay, so this is not the line of regression of y on x. So actually, this is the line of regression of y on x. So what we'll be having here, the line of regression of y on x b. What's that I'll be having here? I can write this as 2x is equal to minus y plus 12, or I can write this as 2x plus y is equal to 12. This is equation 1. And then I can write this as y is equal to minus 2x plus 12. So if this is a line of regression, then what we can have is we have, so we get here b by x is equal to minus 2. Okay. So here we got b by x is equal to minus 2. That is, slope of the line is going to be minus 2. Okay. And I consider this as equation 2. Okay. So now we have the line of regression of x on y b. Okay. So here this is going to be the line of regression of x on y. And so I can write this as, I can write y is equal to 30 minus 6x. So I can write this as 6x plus y is equal to 30. So this is going to be equation 3. Okay. So I can write this as x is equal to minus y by 6, and here we'll be having plus 5. So we'll be having this 6 I am taking on the other hand side. So I'll be having this going to be 5. So I got x now. So this is the line of regression of x on y, and hence what we can have is, so we have, what we'll be having here, bxy is equal to minus 1 by 6. Okay, so here you got bxy is equal to minus 1 by 6. So this is 4. Now you can see both the signs are negative. So that is good. The product is less than 1. So this is the test that you need to understand. Okay, so the product of this bxy and byx is going to be less than 1. Okay, and that's why we have to be careful. So earlier, as we see, it was coming to be 3, which is greater than 1. So we have to be careful. Okay, so here the product is going to be less than 1, and that's why now our assumptions are correct. Our whatever we are going with the calculations, that calculations are going to be correct. Okay, and now see what we want. See, uh, we want to find the value of we want to find the value of x bar, y bar. We want to find the value of r. We want to find out sigma y square. Okay, and so what I can write is here. So consider, so what is r? R is square root of bxy into byx. So what we get here? Square root of, this is bxy. So minus 1 by 6. Okay, and then we have, this is minus 2. So this is going to be minus, minus will become plus, and you'll be having 1 by 3. Okay, so give me the value of r that you are able to get. So I hope you are able to calculate, and then we got r is equal to, so what is the value of r you are getting here? So the r value is going to be 0.5773. What about the others? Are you getting the value of r? Yeah. Okay. Good, Dipesh. Yeah. So you got the value 0.5773. Okay. So we have here is going to be 0.5773. So we got a value 0.577. Okay. So here we got a value of r, and now we want to find what is going to be the so sigma y square. Yeah, what we know is, we know since sigma x square is equal to 16. So what will be having? Sigma x is equal to. So we have square root of 16, that is going to be 4. So we got sigma x is equal to 4. Okay. So we got here sigma x is going to be 4. And hence, what we have any coefficient byx or bxy you can consider. So I'll be having byx is equal to r into sigma y sigma x. So what is this r we have calculated? R we have calculated as or I can write this as. So we are interested in sigma y. So sigma y is equal to this I can have on the other hand side. So sigma x into Eyx upon r. So we got here this is 4 upon 0.5773 and into what is Byx? So Byx we have seen that's going to be minus 2 and hence we got here this is going to be minus 2. So we got sigma y is equal to, so what this value will be having? One more thing that you need to understand is r will be negative. Okay, so as this byx and bxy is negative, r will be negative here. So r is going to be minus. So this r and regression coefficients are having the same sign. Okay, so r will be minus 0.5773. Okay, so here you can write note that r byx and bxy have same signs. Okay, so these all three quantities r byx and bxy have the same signs. So that's why this is negative. That means r is going to be negative. Okay, and r is negative. That means here we have to consider this is going to be minus. So this minus minus will become plus. Okay, and then we are able to get the value of sigma y. So tell me what is the value of sigma y? So you're having 8 upon 0.5773. So what is the value of R you are getting? Sorry, you are getting 13.8564. Okay, so we got here going to be 13.8574. Okay, so that's what the value you got, 76. Yeah. Okay. So we got this value to be 76. So now we have the value of sigma y. So we got this sigma y is equal to, okay, 13.8576, and hence we are interested in variance. So sigma y square is equal to, what is the value of sigma y square you are getting? So give me the value of sigma y square. What is the value of sigma y square? You got 192.0334. That's good. Okay. So you got the value here. So it is going to be 192.0334. Okay. That 0334. Correct. Okay. So this is the value of sigma y square, the variance of y. Okay. And now what do we want? We want x bar and y bar. Okay. So if I want to get the value of x bar and y bar, so what we can say is since x bar and y bar satisfy lines of regressions. Okay. Hence, we have. So what we have here? Yeah. So we got the first line of regression. So I can write this as 2x plus y is equal to 12. So this is 2x plus y is equal to 12. And what we got the next? Next we have this is 6x plus y is equal to 30. So we got here this 6x plus y is equal to 30. So solving above equations, we get. So what you are able to get is x bar is equal to and y bar is equal to. So what are the values of x bar and y bar you are getting? Gaurav got the values. What about others? Pooja also got the values. Yeah. So you are getting the same values. That's 4.5 and 3. So that's good. So this is going to be 4.5 and this is going to be 3. So this way we are able to get required values. So we got the value of x bar, we got the value of y bar, we got the value of sigma y square, and then we got the value of r. So here you need to be careful that the sign of byx, bxy, and r is going to be same, and that's why this r becomes negative. Okay, so that's what we have. Now, do you have any doubt in this question? Do you have any doubt in this question? Is Aarti Erole here? Answer for R. What is your doubt, Gaurav? Yeah, answer for R came positive, so we manually changed. No. When we consider square root, we always have two values. Either we have positive or negative. Okay, so now the question is, what value we have to consider? Whether we have to consider the positive value, whether we have to consider the negative value. Okay, so when we say x square is equal to 4, then what is the value of x we can have? Either we have plus 2 or we have minus 2. Okay, that's why when we consider r is the square root of this byx into bxy, so byx into bxy is always a positive quantity. But when we consider a square root, the square root may be positive, may be negative. But then how we decide the value of r, whether it is positive or negative? Because the remark I have given you that the sign of bxy and byx is always same. This is the one remark I have given you. And after that, the sign of r, bxy, byx is same. And now you can see in our example that the byx is also negative, bxy is also negative. So that implies b xy, byx, and r all are negative. Okay, so that's why we have changed the sign to minus. Okay, otherwise square root has both the signs, plus and minus. Okay, that's great. Good. So let us go for the another example. If you don't have any doubt in this example, so do you have any doubt now in this example? Okay, that's great. So let us go for the another example. So we have the another example then. So which is very similar again, but here instead of symbols, that is mention in words. Okay, so what we have here, the mean values of x and y. So what it means is the mean values of x and y, it is going to be x bar and y bar. What is the correlation coefficient? So that is going to be small r. And then the standard, we have to find the standard deviation of y if standard deviation of x is 3. So that means we have to find sigma y when sigma x is 3. Okay, so this is how we need to understand what is given and then what we want to find out. And then it is given these are the two lines of regression. So again, we have to check. Okay, so how or what these lines are correctly. So first we have to identify the correct lines of regression. That means which of this line is for x on y and which of this line is for y on x. Okay, so for that what we have to do is we just have to do a rough work. Okay, so what is the rough work we have to do? For example, if I consider this line as a y on x, so I consider y on x. So what if I consider this as y on x, then what will happen? I'll be having 5y is equal to 4x plus 33. So y is equal to what will be having 4 by 5x plus 33 by 5. So this is the slope for this line. And for this line then, if I consider this is x on y, so what will be having 20x is equal to 9y and plus 107. So it will be x is equal to 9 by 20 y and plus 107 upon 20. Okay, so now this is going to be the slope. So what we have to do is this is our byx and this is bxy. Calculate byx into bxy. Okay, so what we'll be having here, this will be 4 by 5 into 9 by 20. And hence, what you can have is going to be 5. So it is going to be 9 by 25. So it is less than 1. So if it is less than 1, that means these are correct lines. Okay, so if it is greater than 1, that means it is wrong. Because R we have maximum 1. So R square will be maximum 1. So if this term goes more than 1, then it is not correct. If this term is less than 1, that is correct. So it is going to be 9 by 25. So it is correct. So this is the line of regression of y on x, and this is the line of regression of x on y. So this is y on x, and this is x on y. And once you understand this, then only you have to start solving the problem. So then only correctly you can solve the problem. So what I'll be having here, let the line of regression of y on x b. Okay, so what is the line? We'll be having 4x minus 5y plus 33 is equal to 0. Okay, so once you identify the correct line, that means other is the remaining one. Okay, and this is all rough work. So we don't have to write it here. So this is all rough work that to identify the lines of regression. So I can write this as, so this is going to be 4x minus 5y is equal to minus 33. Let this equation 1. And I want this in terms of y. So I'll be having 5y is equal to 4x plus 33. So I can write y is equal to 4 by 5 x plus 33 by 5. So from this equation, I am able to get the value of p by x. And hence, we have p by x is equal to 4 by 5. So this is the value that we want to use later. And hence, I'll highlight it and make an equation. Okay, so I can refer later on. So what we'll be having now, the next, the line of regression of x on y b. So what is the next line given to you? See, 20x minus 9y minus 107. So we have 20x minus 9y minus 107 is equal to 0. Okay, so that's what we have. Okay, yeah. And hence I can write this as, so I can write it as 20x minus 9y is equal to 107 at the equation 3. And then we want in terms of x. So if I want in terms of x, I'll be having 20x is equal to 9y plus 107. Or I'll write x is equal to 9 by 20y plus 107 by 20. And once you get this equation, you are able to get the coefficient of regression coefficient. So we have what will be having bxy. So coefficient regression of x on y. So it is going to be 9 by 20. Okay. So once you get this coefficient regression, then we'll be having this is equation 4. Okay. So if I want to find out r, then I have to use equation 2 and 4. So what I can write is from equation 2 and 4, we have what we'll be having r is equal to square root of byx into bxy. So it is going to be square root of 4 by 5 into 9 by 20. So you got this. So this will be 9 by 25 and it is going to be 3 by 5. So it is 0.6. Now tell me whether it will be positive or negative. Whether it will be positive or negative because I am considering the square root. So whether it is positive. Why it is positive? Why it will be positive now? Correct. So you have byx and bxy are positive. That's why r is positive. Correct. Okay. So you got the idea now how to decide the sign of the coefficient of correlation. That's good. Okay. So great. Now you got this is going to be 0.6. So I can write this as we got r is equal to 0.6. Okay, which is positive. Okay. And now what I want to find out the value of sigma y. Okay. So I have to find out sigma y when sigma x is equal to 3. Okay. So what I can write is then we have okay. So we have sigma x given to be 3. Okay, r is equal to 3 by 5. For the simplicity, I am using this value so I can cancel out. Okay, and hence p x y is equal to r into sigma x sigma y. So we are interested in sigma y. So sigma y is r into sigma x upon p x y. Okay, so r is 3 by 5. Sigma x is 3. pxy. So what is pxy? 9 by 20. Okay. So I can write this as going to be 9 by 20. Okay. I'll write this as 9 by 20. Okay. So we can write this as 9 by 5 into 20 by 9. So this I can write it like this. And hence I'll be having this is going to be 4. So 9 will get cancelled and you'll be having is going to be 4. Okay. So we got sigma y is equal to 4. Okay. So this way we got sigma y. Okay, we got r, and now what we want to find is we want to find what is x bar and y bar. Okay, so for x bar and y bar, we have to use equation 1 and 3. Okay, so that we are able to find the x bar and y bar. So I can write here since x bar and y bar satisfy lines of regression. Okay, hence we consider equation 1 and we have. So what is the equation 1 we have? See, it is going to be 4x minus 5y is equal to minus 33. So we got here is going to be 4x minus 5y is equal to minus 33. And what is the next equation we have? So we have 20x minus 9y is equal to 107. So it's here 20x minus 9y is equal to 107. Okay. And hence what we can say is solving above questions we have. Okay. So what will get x bar and we'll get y bar. Okay. So what is the value of x bar and y bar you have? Great. Okay. So we got a value of x bar is equal to 13 and y bar is equal to 70. Is that true? Yeah. Okay. So that's what we have here. So we got the value of x bar. We got the value of y bar. Okay. So that's great. Now, yeah. So I'm good. So you got the values of x bar and y bar, and you got the values of r. You got the value of sigma y using the value of r and using the lines of regression. So now, do you have any doubt in this example? That's great. Okay. So basically, when we started with the data analysis, okay, the first tool that we try to understand was the coefficient of correlation. So we started with the correlation of coefficient small r. So what the small r gives, the small r gives us the idea whether there is a relation between the given data or not. If there is a relation, okay, up to what extent or what confidence level we can say that there is a relation. Okay, and once we have the confidence that there is a relation, then we try to know whether the decision that we make is correct or not by using the rank correlation coefficient. Okay, or is there any biasness in the decision making? So that we have tested using the rank correlation coefficient. And now, after that, once we were having the confidence that there is a relation between two data sets, okay, then we calculated what is the relation. Okay, and here we use the tool was a regression. Okay, so this is called regression analysis. Okay, because these data sets we are considering as a variable, but they are the attributes. Okay, we don't know whether they depend on each other or not, and that's why we try to find out the relation between them, and then we got the relation by using the regression. So here we consider the linear regression precisely. Okay, so when you go to the regression analysis, there are the linear regression, there is a non-linear regression. So when we go to the non-linear regression, what kind of non-linear regression we can have? Okay, so we can have the regression of degree 1, so which is called linear regression. Then we have the linear regression, non-linear regression, so which is of degree 2 and 3 and 4 and like that. Okay, so now here we try to fit a line, okay, regression line using the small r, that what level of confidence we can have, and then we calculated the lines of regression. We calculate in either way. So we have calculated for y on x, and we have calculated for x and y also, and now we have to go further. Okay, so whatever we have done up to it, that's good. Okay, so see, we have reached to the linear regression, we can understand. Okay, what about the non-linear? Okay, so we know one technique. Now we have to go to the another technique. Okay, and in another technique, we call that fitting of curve or curve fitting. Okay, in your second semester, you have seen the technique curve tracing. Okay, or finding the curve how or where it lies when you know the equation. Okay. Now here I know the data points and I want to find the curve where it lies. Okay. So if I know the curve, I am able to find the link. But here I want to know the curve now. Okay. So here, yeah, in not in double integration, the chapter was rectification that you did. Okay, you calculated the length of the curve, and to know the length of the curve, first you know to you should know to what is the curve, and for that you did the curve tracing technique. But in curve tracing, you are knowing the equation of the curve. Okay, here we do not know the equation of the curve. We have to find. Okay, so here we have to find. So basically, to understand this technique, we'll consider two types of curves. Okay, so what are the two types of curves? We'll consider one linear and one non-linear. Yeah, so linear is a simple line. What is the non-linear curve? That we need to understand. So the non-linear curve of second degree. Can you guess what is the name of this curve? Non-linear curve of second degree. You have studied it, definitely. You know it. So yes, want to know whether you are able to guess it or not. Quadratic. Yeah. But what is the name? We when we say polynomial, we say quadratic polynomial. But when we convert it to curves, then we have a name for this curve. Yes, Sagnik got it. Great, good. Akhilesh also got it. So parabola. Okay, good. Okay, so you remember. That's great. Okay, so here we are going to see two curves. Okay, one is the line. Line is also called the curve of first degree. Okay, so line is also called as the curve of first degree, which is very basic relation. Okay, basic relation. Anything you want to test it for line. Okay, so that's what we have to do. And then the next curve will go for, we'll increase the degree of the curve, and then we'll consider it to be the parabola. Okay, or it is also called as the second degree curve. Okay, now the question may be then why not the circle? Circle is also having the 2 degree, but when we consider a circle, okay, it's a closed curve. Okay, when we consider the data sets, most of the times it is open, and that's why we prefer parabola rather than the circle. Okay, so other circle, ellipse, these are not the curves to be considered. So we consider only the parabola. Okay, now the idea is what is the next technique that we are going to use. Okay, so you got the names of the curve what we are going to play with. Okay, so these are the curve, line and the parabola that we are going to fit, or we are going to find the relation, whether there is a linear relation or whether there is a non-linear relation, and if it is a non-linear relation, whether it is a parabolic or not. Okay, that we are going to see. Now we know one technique. That what technique we have seen is just finding the coefficient of regression and then putting it to the line. Okay, but this technique is easy for linear regression. Okay, so this technique is very easy because you can find a byx for line. Okay, then what about the second degree curve? Okay, so it becomes difficult. Okay, because we don't know what is the equation of the line, and then if we consider the slope of this curve. Okay, so suppose I want to find the slope of this parabola, then what I'll have the first order derivative, but that first order derivative will be itself in terms of x. It will not be a constant. In case of line, the first derivative is always a constant, and so that constant gives you directly the slope of this line. But in second degree, it is not so, and that's why we have to change the technique. Okay, so the question is, what technique you are going to choose? Okay, so now the technique that we are going to choose is called the least square method. Okay, so we are going to change the technique, and that technique is called the method of least squares. Okay, now why it is called the method of least squares? Why it is not the called as method of maximum square, or why it is not called something else? Okay, so why it is called as the method of least squares? This squares are nothing but the squares of errors. Okay, the squares are nothing but the squares of errors. So if the square is, if the error is less, then its square will be more or less. Okay. So for example, you find out the square of 0.35 and the square of 0.25. So you will have the square of 0.25 will be less. And if you go for again square of 0.05, it will be again less. Okay. So that's why we use a technique of optimization. So you have calculated maxima and minima in your first sim, and then here what we are going to do is we are going to minimize the square of these errors. Yeah, what we are going to do? We are going to minimize the square of these errors. And when the square will be minimum, obviously the error will be very small. Okay, and that's why this method is called the method of least squares. Okay, so now using this method of least square, we'll see how to fit a curve. Okay, so let us have the next topic, which we want to go for curve fitting or fitting of curve. So now we have to consider the topic curve fitting. Okay. So here we have to consider the two types of curves. One is linear curve and other is non-linear curve. So here we have first degree curve, or this is also called as line. Okay, so we have first degree curve, and this is called the line. So what we have to do here? Okay, what we'll be having? Let y is equal to ax plus b. Okay, this is equation one being the curve of degree one, or be the line. Yeah. Then the normal equations are given as. Yeah. So before I write the normal equations, you need to understand this is the line. Now y and x are not only 1 points, but these are the data sets. Okay, so x is a data set, y is a data set. So these are the data sets, and then we have to find the coefficient a and b such that this line is satisfied. Okay, so here you need to be careful. Okay, what you need to be careful is that see, x contains so many points. Okay, as it is a data set, y contains the same number of points. Okay, so x and y are the known values here. Okay, and then tell me what are the unknowns in this equation? See, x and y are the known values. So generally what happens is x and y are unknowns. But here in our case, x and y are known values, correct? So a and b are unknowns. Okay, so we have to find the value of a and b. Now you have seen the matrices, you have solved the system of linear equation in SEM 1. Okay, so please tell me how many number of equations you require to find the unique value of two variables. Yeah, we have two variables now, a and b. So how many equations you will need? Yeah, that's great. So you have studied matrices very well. Correct. Advait, correct. So simultaneous two. Great. Okay, I'm very happy to hear that you remember. Okay, so we require two equations. Okay, but the values, okay, the values are many, more than two we have. Okay, so x values are more than two, y values are more than two. So if I consider only two values or only two pairs of x and y, then I will get the line. But may possible that I will not get the best line. Okay, and here we have to choose the best line. Okay, so I have more than 2 points, but I have to choose the best line, and that's why to choose the best line, we are using the technique or the method, least square method. So from this least square method, using the least square method, I have obtained the normal equations, and that's why these normal equations in the case of line will be 2. So what are these normal equation? Let us see. So I have to consider all the points here, and hence the normal equation for the line are given as, so this is summation y is equal to a summation x plus n times summation n times b. Okay, and we have summation, multiply this equation by x and then take the sum. So xy is equal to a summation x square plus b summation x. Okay, so what you'll be having here, where n is equal to number of observations. Okay, so here what we have these are the number of observations. Okay, so as we know, we want to find the value of unknown values of this a and b. So a and b are unknowns for us, and that's why we wanted a two equation. So I have considered the two equation, but this x and y are the data sets. I cannot consider only one or two values or a few values out of this. So I have to consider all the values, and that's why I have considered all the values of this y by considering summation y, and all the values of x by considering summation x. Okay, so these are the normal equations we get. And now once I have the normal equations, I need to know what I have to find. So I have to find summation x, I have to find summation y, I have to find summation xy, I have to find summation x square. And once I get these values 1 2 3 4 and n, I can count the number of observations, so 5. Then once I know these 5 values, then I can form a matrix or I can form simultaneous equations. And once I form the simultaneous equations, I am able to get uh, the solution of this simultaneous equation. And then I am able to get the values of a and b. And once I get the values of a and b, after solving this simultaneous equation 2, I am able to write the linear relation or the equation of the line or the curve of first degree by using these values a and b. Yeah, so this is about the line. Now we have to think of the next curve, nonlinear curve. So we consider that to be the parabola, or we know the second degree curve. Okay, or this is exactly parabola. Okay, so in question, it will be given to you as the fit the second degree curve, or fit the first degree curve, or fit the line to the following data, or fit the parabola to the following data. So you must know all these terms that they are going to be saying. Now the second degree curve parabola. So what we are aware is, see, we are aware as y square is equal to plus or minus 4ax, and x square is equal to plus or minus 4by. Yeah, so these are the standard parabolas you are aware of, but the equation of parabola is not exactly like this. Okay, so these are the standard equations. Okay, so we don't have to go to the standard equations. We don't know whether we'll get the standard equations always or not. Okay, and so we have to write the general equation. Okay, so the general equation of parabola is that y is equal to ax square plus bx plus c, equation 1, b, the second degree curve, or in bracket, this is going to be parabola. Okay, so this is the parabola we have. And now I want to fit this parabola. So what is known to me? X is known to me, that means x square is known to me, y is known to me. So how many equations we have to consider? What are the unknowns here first? What are the unknown values? I know x, so I know, yeah, that's good. You got this now. Okay, so the unknowns are A, B, and C. Great. Then how many equations I need to solve this, or how many equations I need to find? Yes, that's very nice. Okay, so you need to know the three equations. Okay, and that's why I'm using again the technique of least square methods. Okay, and using the least square methods, I'm getting the normal equations. So let us write what are the normal equations we have. Okay, so we have the normal equations as we have the normal equations as. So what we have to do is take the summation of all this. So we'll be having summation y a times summation x square plus b times summation x plus nc. Then you'll be having summation xy. Multiply by this by x and take the summation. So you'll be having a times summation x cube, b times summation x square, c times summation x. Again multiply by x. So now you will have to multiply this by x square. So what I'll be having here? Summation x square y, a times summation x raised to 4, b times summation x cube, c times summation x square, and this is all you'll be having equation 2. Okay. So where you have, okay, so where n is equal to number of observations. Okay. So what we have here, we have the number of observations. So you can see now for the first degree curve, we got the normal equations, and then for the second degree curve or the parabola, this is the general parabola. Okay, so for the general parabola, we have obtained this normal equations by using the method of least squares. Okay, and so using the least square method, we have obtained this normal equations. And now, once we know what is the value of x, what is the value of x, so x and y, and then we are able to calculate x square, we are able to calculate x cube, we are able to calculate x raised to 4, we are able to calculate xy, x square y, and so once we know all these summations, okay, we are able to put the values of this summation here, and then we are able to find the solution for this three simultaneous equation in three unknowns. So here A, B, and C are the unknowns, and once you have these unknowns, once you find these unknowns, then you are able to put these values in equation 1. So you are able to fit the nonlinear curve to the given data set. So you will get y is equal to ax square plus bx plus c. So now one important thing that you need to understand is these normal equations are for this curve. Okay, so if you change the equation of the curve, then your normal equations will change. Okay, so that's why please follow only one notation. Okay, do not go for the different notations. So if you go for the different notation, then you will be in trouble because the normal equations you will get will be according to the curve. Okay, so whatever the curve you will write, according to that you will get the normal equation. Okay, and I have given you the technique how to write the normal equation. So once again I'll show you that how to write the normal equation for any curve. Okay, so we have see this. I'll show you the technique how to obtain the normal equations. Okay, so here we got this. So what is the curve? The curve first we have considered y is equal to ax plus b. Okay, what is the first normal equation we got? We got summation. Okay, y is equal to a summation x and we got here NB. So what is this NB? Is actually here you're having summation of yi. I will be running from 1 to n. So this is I will be running from 1 to n. So here you will be having b will be running from 1 to n. So what is that? B plus b plus b plus b. It will be n times, which is same as n times b. And that's why I have written here n times b directly. Okay, now what I did to obtain the next, multiply this by x. So you got xy ax square plus bx, and then take the summation. So summation xy is equal to a times summation x square plus b times summation x. And you can see these are the normal equations. Only we do not write now I is running from 1 to n. So it is obvious case I is running from 1 to n. Okay, and that's why this is how you are able to get the normal equation for the line. And now you want to see what is the normal equation for the parabola. So what is the curve we have? Parabola is y is equal to ax square plus bx plus c. So take the summation. So we'll be having summation y a times x square plus b times summation x. And as we get here nb, we'll get here nc. Then multiply this by x. So xy ax cube plus bx square plus cx, and take the summation. So summation xy a summation x cube b summation x square c summation x. Again multiply this by x. So x square y a x raised to 4 b x cube plus c x square, and then have the summation. So you get the summation x square y a summation x raised to 4 b summation x cube c summation x square. Okay, so this is how we are able to get the normal equation. No need to by heart anything. Okay, just try to understand the technique. You don't have to by heart what these equations are. You just need to know what is the curve that you have. So depending on the curve, you are able to write the normal equation of any curve. So if I give you now the third degree curve, you are able to write the normal equations. You don't have to calculate much more. Okay, so this is the technique of writing the normal equation for any curve, any polynomial curve. Okay, so that's why uh, we need to understand the technique. Okay, we don't need to know the calculations, more calculations. So you don't need the calculations anymore, but you need to understand the technique. Okay, and that's why I have given you the technique that how we are able to get the normal equations for this curve, and these normal equations are obtained using the technique of least square or the least square method. Okay, so do you have any doubt in this normal equations? No. Okay, uh, that's great. Okay, so fine.